We're inside the Tantec Lab today to show you the process we go through with doing a free sample trial of your parts. We've got our servo slide table here. This is going to allow us to go ahead and move your parts at your production speed. So the first thing we do when we get your parts in to go ahead and do the sample testing is we confirm your production speed, the part, and the area that you want the treatment to be performed on. We're going to be working on atmospheric plasma. We also have corona as well, which we'll be doing some testing on, and vacuum plasma. So we can also look at different ways to treat your part based on your production process. The first thing we do is we get set up with the atmospheric SpinTEC 30 here. We also confirm our gap is in the position that we want it to ensure that the treatment is hitting the most effective area of the part and covering the area you're most interested in. After the treatment takes place, we'll go ahead and do a test of your part with either a contact angle or a dyne solution. That allows us to go ahead and confirm the surface energy that you're looking to achieve has been able to be achieved during the production process of the plasma hitting the part itself. Once we're all set and ready to run, we go ahead and set the line speed on the machine itself. We'll go ahead and pass the part underneath here. The plasma will hit that specified area at your production speed, allowing us to confirm we're able to meet your expectations. We're here in the Tantec Lab to demonstrate some of our corona treatment capabilities. Again, when you send your parts in for a free sample test and you're looking for a corona treatment process, this would be the type of setup we would use to go ahead and confirm that we can change the surface energy of your part. The part that we have here is a foam board. This is a thick board that would fall in line with our SpinTEC product. So we've got a special electrode here. This is a wire electrode. It is a simple 4-inch wire that's connected to our high voltage transformer, which is then connected to our power generator. Those are the core components needed in order to create a corona discharge for the Tantec systems that we produce. So once we're ready to go ahead and do the treatment process, we go ahead and set the electrode into position. We go ahead and activate the corona treatment, and we simply traverse the electrode across the surface of the part, mimicking the movement of a sheet through a machine at that point. So what this is doing is actually creating the change in surface energy we're looking for in order to improve the coating, the adhesion, or the print quality onto the foam itself. So you'll see later on in the test, we're going to go ahead and place some tape on the surface and confirm that the surface energy is improving the adhesion of the tape to the part itself. One of the great things here at Tantec is because we do focus solely on three-dimensional surface treating and thick 2D products, we're able to go ahead and very quickly change out the electrode design in order to treat a different part. So I'm going to do that here real quick. We're going to remove the electrode and change out the end effector to give us a different look and feel to the corona treatment process and treat a different part. So with a quick 5-second change here, we're now using a ball electrode. This is going to be on a petri dish where we're simply just going to go ahead and activate the discharge, where you'll be able to see the difference in how the corona discharge takes shape on the product. However, the treatment effect that we're looking for should be the same as the previous electrode. As you can see, a very, very quick, easy, simple process in order to go ahead and make that change for a different product. We look forward to receiving your samples and providing you a test report on what Tantec's corona treatment can do for you. In the Tantec Lab, one of the technologies we utilize for sampling and testing parts is our vacuum plasma technology. This technology might be implemented simply because our customer is already using a vacuum plasma process, maybe wants to use an exotic gas to do a specific chemistry on the part, or a conventional corona or plasma is not capable of reaching the area or geometry that they want to treat. So inside the chamber, parts are loaded onto this tray. We've got electrodes on the top and the bottom that are going to create a plasma field that will effectively treat the entire surface of the part. So once the door is closed, we remove the air from the vacuum chamber down to about 1 millibar. We'll ignite the plasma at that point. After the process is completed, we can then take a measurement using dyne or contact angle to once again verify that we actually are changing the surface energy of the part, ultimately being able to send samples back, allowing our customers to confirm that the adhesion or the coating was able to be achieved with this resultant surface energy change. During the lab testings of your parts that you sent in for Tantec to do the sample work on, we're going to do a dyne test measurement. The first will be on a part that has been untreated to measure the surface energy before treatment, and then we'll take your part and we'll go ahead and measure the surface energy after treatment, looking for that change from either a plasma or a corona treatment that's been applied to the surface. So the first part we're going to do here is an untreated part. We're going to go ahead and put a 40 dyne on the surface. We're going to look at how this bead of ink or liquid appears on the surface. We're looking for it to wet out or pull back. If it pulls back, that means we're below 40. If it wets out, we're higher than 40. Most untreated parts that come in are going to be below 40 dyne, and that's usually where you start to see the adhesion problems on plastic materials. So the first test we'll do here, we'll wipe it on the surface and look for how this bead reacts. As you're able to see, the bead is simply just a small dot on the surface. Nothing has spread or wet out at that point. So that would tell me that this is an untreated part with a dyne level below 40, which is again why we would look for surface energy change with corona or plasma to improve adhesion and wettability. So this part in the back we've treated with atmospheric plasma. I've got a 60 dyne here that I'll go ahead and wipe on the surface to measure the surface energy. And you can see on this test, we're actually above 60 dyne. We're completely wetting out. We've got a nice wide bead of liquid on the surface and nothing has pulled back. So this is what we would do typically on any type of surface energy testing. For somebody's samples that they send in, we can do dyne testing, and this is a methodology that we do for all the testing and document this in the report we'll send to you. Sometimes here in the lab at Tantec, we receive samples in from customers that are more of a porous material, which make traditional contact angle and dyne testing really challenging because of the absorption of the liquid on the surface. So what we do then is we do what we call a tape test. What we're looking for is how well the tape adheres to the top surface on a foam piece like this. So on the front piece, we have an untreated foam board. On the back, we have a treated foam board. Simply place the tape down on the surface and we do a peel test up to look for any foam transfer or how easily the tape removes itself from the surface. So on the untreated piece, simply pull that up and you can see how quickly and easily the tape removed itself from the foam. The foam looks like it's intact. There was no tear or adhesion improvement on the surface with that tape. Now we go to a treated part. We go ahead and start lifting that up and you can instantly see and hear the effect of the foam adherence to the tape. So this would tell us that our corona or plasma treatment in this case made a substantial impact on the adhesion properties of the foam. In our Tantec lab, we've invested in some advanced measurement systems to determine the contact angle of parts after surface treatment. A lot of our customers require this or have requested this type of measurement because they already have a system in-house for quality control. We take a micro-dosed droplet of deionized water and measure the angle of the droplet, determining the surface free energy and the contact angle. The lower the contact angle, the better the surface properties are. We've placed the part on the platform like this. So the software that dispenses the deionized water onto the surface measures the contact angle for us, giving us a very, very accurate value of the contact angle and surface free energy. This differs from doing a dyne test, which is very subjective based on the operator's interpretation of how the dyne is working and reacting to the surface. Contact angle is essentially the gold standard for measurement in our industry.